Shaja Miss, can we start?
Yes, sir.
Yes, sir. Shall I start?
Yes, ma'am. Okay.
Respected speakers of the day and dear participants, good evening to you all. It's my immense pleasure to welcome you all to the day 4 sessions of FDP on behalf of Nirmala College Fraternity. Today, the first session on post-disaster management using AI technologies is handled by Dr. N. Subbarani, Associate Professor, Department of Computer Science and Engineering, Dr. Mahalingam College of Engineering and Technology. The second session on data-driven decision-making in healthcare using AI and innovative statistical methods is handled by Dr. Jindo J. Potakal, Manager, Statistics, GlaxoSmithKline, United States. At the end of each session, the participants can enter their queries in the chat box or unmute your audio for asking questions directly. The link for feedback form also issued at the end of each session for the attendance purpose. Now, moving on to the session, it's my privilege to introduce and welcome the speaker of the session, Dr. Subbarani. Dr. N. Subbarani completed her doctorate in Information and Communication Engineering from Anna University in the year 2017. She is currently working as Associate Professor at Dr. Mahalingam College of Engineering and Technology, Tamil Nadu. She is having over 18 years of experience in academics and research. She has served for more than a decade as head of the department and in various administrative roles. Her research interests include network security, cloud computing, data science, and machine learning. She has published around 20 papers in reputed journals and guided 20 plus UG and PG projects. Her achievements include receiving an AWS Academy badge, the Best Faculty Senior Category Award from PA College of Engineering and Technology, and the Gold Medal from NIA Educational Institutions. Ma'am, we are really honored with your presence. I extend a hearty welcome to you, ma'am.
Thank you, ma'am. I first of all congratulate. Is my voice audible?
Yes, ma'am.
Yes, ma'am. Yes.
Yeah. Okay. I think my screen is also visible to you all.
Yes, ma'am.
Yeah. Thank you. Thank you so much, Mr. Sherin. I first congratulate the entire team of Nirmala College for organizing an ACT training and learning academy online faculty development program on advances in AI applications and ethical dimensions in intelligent systems and digital security. It is not the one day work, but you have given a lot of effort for the past 3 months to 4 months in order to make this event. So I first of all congratulate the entire team, the coordinator, Dr. Thomas, director, the core coordinator, Ms. Sherin Panikar, head of the department, the organizing members, Ms. Elizabeth, Mr. Sherin Matthew, and all organizing and committee members for making this a grand one. So that session for the day 4 is post-disaster management techniques using where we are applying AI technology. So what is disaster? So a disaster is nothing but a sudden event that happens for a community or a society. So it may be a natural disaster or a man-made or a hybrid, which we have heard it's common now in nowadays. So there are different types of disasters like natural disaster, which is not in the limit of human beings, like earthquake, flood, volcanic eruptions, landslides, and epidemics. The other type of disaster is man-made, where the industrial accidents like chemicals or gas leakage, nuclear accidents, transportation accidents, fire, and some environmental pollutions. And coming to the third type of disaster is hybrid, which is a combination of nature and human, like climatic change, deforestation, and poor sanitization. This all leads to a disaster. So, why do you want to talk about these disasters? Because we are coming across a few more disasters in nowadays. When we try to rank the types of disasters, the first place comes the type of disaster that occupies the first rank is your flood. So flood And then comes the storm or cyclone or hurricanes. And next we have extreme temperature like heat waves and droughts. And next we have got earthquakes and
Excuse me,
wildfires.
ma'am.
Yes,
Excuse me, ma'am. Is your video off or it's set like that?
yes, my video is on. Do you have?
It's not on for us here.
Uh, Let me check, ma'am.
Okay, ma'am.
Maybe the signals, due to signal, the video is not.
Okay, ma'am. Yeah, it's on now. It's visible now.
Yeah.
Yes, ma'am. It's visible in your screen, in your laptop, not here in the meet, I think.
Okay. Okay.
Okay.
So next we have why we have gone for this type of disasters, because it is many. Why we need to talk about this, because it is giving a great challenge like global economic losses. Because of this disaster, the economic loss of each country is very huge, which is not known for a normal human being. So in order to reduce the economic loss, which could help the development of a country, we have to study about those post-disaster management techniques, which an AI can help us. So, in the reason for the past 30 years data, we could see that trillions and billions of economic losses has been there in around the world, and it is a global loss also. And when we talk about the countries, so each country has got different types of disasters. So most the highly when we rank the disasters and exposure of the countries, we could see that Philippines, Indonesia, India, Colombia, Mexico, Myanmar, Pakistan, and Bangladesh are well exposed for these disasters. So it's a high time for us to include our AI techniques in order to prevent it. But natural disaster cannot be stopped by any human being, but at least we can reduce the loss, like economic loss or human loss. So, what is the challenge of this disaster? Is there is growing a frequency and intensity of nature and man-made disasters nowadays. So, it is very huge loss for human being as well as for the country, which is in a developing stage. So traditional disaster management faces very less limitations in terms of speed, accuracy, and resource allocation when the disaster is on. The critical need is we need to find an innovative solutions in this post-disaster phase. So when we talk about the phases of disaster management, we have mitigation, preparedness, and recovery and rescue. So some activities has to be done before the disaster. Like activities prior to disaster, we call it as pre-disaster management. And the activities that has to be carried out during disaster, we call it as post-disaster management. So we should have a prepared plans and emergency trainings and installation of warning systems and public awareness, education. These all to be activities that has to be done before a prior disaster. It may vary from type of disasters and place of disaster. And also we have to enforce some laws which a government has to be done in order to give a safety regulations for the citizen. Coming to the activities that has to be done during disaster, we have to have an activated public warning system, and we have to have a good trained resources for searching and rescuing. We have to have a well established operations and cleanups, and we have to see a temporary housing and some arrangements for the victims. So these are the stages where we have to think about the disaster management. So post-disaster management is the activity that has to be taken after the disaster in order to restore the normal as quick as possible for the affected communities. So different phases of this post-disaster management is immediate relief and rescue, damage assessment, resource allocation and logistics, reconstruction and rehabilitation, and long-term resilience building. Why we need an AI for this post-disaster management? As you know, data is on large scale. So we have lots of data from satellite, social media, even sensor data. So these data can be processed in a very large scale, and AI can produce the data, which a normal human being cannot. With a huge such data, it is unable to predict by a normal human being. A real-time insights. So it provides an immediate and actionable intelligence for the responders. So what type of activity is immediate? So actionable plans can be executed. And next, coming to the preventive capabilities or predictive capabilities. So preventive, we can also prevent it, and also we can predict what is the forecast of what will be the impact of the resources currently. And next, automation. We try to automate the repeated task in order to free the human resources. We can't monitor all the 24/7 on all days, but an automation helps us to monitor the climate. So it makes a repeated task and free up the human resources. It is not that we are not including humans, but a repeated task can be reduced by automation. Next is optimization. We'd like to improve the efficiency by optimizing the resources, because the disaster cannot be happening at a single point. It will be spreading all over. So we have to manage efficiently the resources. With the available resources, we have to make the resource allocation and logistic effectively. So the four stages of this post-disaster management is: first, you have to assess. So what is the level of depth of damage? This can be done by a satellite analysis. And next, how the victims can be identified or detected, and how the resource can be managed. Next, coming to the recovery stage, we have to monitor the health of the victims, and we have to take the necessary decision supports. So here comes the decision support systems to recover the victims. And resilience is that what we have to do for the future infrastructure planning and long-term assistance. And there are more research opportunities when we talk on this post-disaster management. The first is automatic building damage assessment from multi-sensor imagery. So as you know, we have got more satellite images, aerial images, which we can capture through drones. And using these images, it is easy for us to automatically build a damage assessment. So we can easily press what is the damage. So now we call it as digital twins, where an actual image can be modified as an image after damage, and it can show how the damages would be, what will be the depth of damages. And second opportunity is, since we have got different types of images, it can be optical or a radar image or a drone image. So these images should be very clear even at night time. So the cross-model change detection is very important, and this also gives a high opportunity to do research. Coming to the third opportunity is fine-grained infrastructures and damage and accessible mapping. So beyond buildings, what is happening? Beyond the power line, what's happening? This predicting the scores of the emergency teams to route how we can enter it into an infrastructure when the disasters happen. Next, we have got real-time social media data. Once the disasters happen, we get more of data around the social media, even sensors, and more from contacts. So these SMS logs and IoT sensors may be taken for us as an input. Next, coming to the LLM assistant information. So we use LLMs to synthesize the incoming reports, and we generate the brief and localize messages, and we create the prioritized tasks to list for the responders. So we Based on this, we have additional research opportunities like resource allocation and logistic optimization. So based on the damages, we try to estimate and optimize the resources. Next, when we talk about the human robot teaming, so we have to train the robots where when the disaster happens, it may not be able to reach, humans may not be able to reach all the areas. So we train the robots in order to reach like drones or ground robots where that can be moved in order to detect the victims. Some, like for example, in the case of landslides, the humans may be buried inside alive. So some people may be alive. So we have to identify the victims, those are alive, and we have to take a stringent and immediate action in order to uh, help them and remove from that buried place. So this is where a human and robot should be teaming. Next, we have got an explainable and trustworthy AI for taking decisions. Since then it is a natural disaster, it is very confusing stage to take decisions. Some decisions may not be taken immediately. So it has to improvise the decisions and have to be fact checks so that we rescue the maximum victims in that affected area. And next is few shots of learning for rare events like developing a methods to generalize the novel disaster types, how to categorize the area, how and label them. And next is automated damage to loss estimation. In order to, we can also estimate the economic losses that happen because of this production, or even you can predict if a particular site is going to have a disaster. You can also predict what would be the loss after disaster. So this is a forecast of how to predict the loss for the disaster. And next, we have got anomaly detections. This will help us to detect the secondary risk. What are the possibility of coming, monitoring it in a remote sensing, and what will be the secondary hazards that will be happening after the disaster. And next is, as usual, we have data security as an opportunity where we have privacy preserving data and sharing the federated learning model for multi-agency collaborations. So these are the areas where we have got opportunities to do research in post-disaster management. Let's see one by one. First is the AI in damage assessment. So we need computer visions like CNN, OLO, and UNet mass algorithms which help us to analyze it. The images that can be used to analyze it. And we use machine learning algorithms to classify what is the severity of damages like moderate or minor or severe. So when coming to the manage impact of damage assessment, we have got many algorithms which help us to assess the damage. So AI has got more role in order to use this. And one of the case study that we could take us, one concern, which is in California, has taken is the AI which has adopted the AI technique, and it has reduced the damages that could occur by alerting the people. So it helps us, what is the impact of this is, it is faster understanding the scope of disaster, prioritization of rescues, and we have got effective allocation of resource, reconstruction resources. When we talk about the next priority is resource allocation and logistics. When we come to the post-disaster management, resource allocation plays a major role in order to, with limited resources, we have to plan accordingly to in order to reach all the victims and to rescue them. So we have to predict the analytics and see, forecast what is the demand and supply like food, water, or medical aid that is required for this damages. And also we use optimization algorithms, determining the optimal routes for getting the aid delivery and how to reach it on time. And coming to the third is geospatial AIs, where the location may be very remote. So we have to effectively deploy the personals and equipments based on this geospatial AI. So the impact of this gives us to ensure timely delivery of critical resources, minimizing the waste and maximizing the impact of aids and improving the coordination among the relief agencies and also to to reach the victims as soon as possible. Next, we have got AI in communication and information management. So when we talk about the communication and information management, it can be we'll receive a lot of communications after the disaster. So we need to analyze the data, like the data that are posted in social media and even the emergency calls and text messages to identify the distress signals rather than the real-time suitable awareness. So we will play a natural language processing plays an important role. And we have to have an automated chatbots and virtual assistants because limited human beings cannot address all this. So we have to provide a real-time information to the affected population. So we use this chatbot. Next, we have got sentiment analysis, where we understand the public moods and immediate concerns. So this helps us. The impact of this is improve communication between the responders and affected communities and faster dissemination of critical alerts and informations and better understanding on ground needs. So this helps us to know what is the actual need for a affected area. So these are some real world applications that has been implemented, but unfortunately is not in India. So since India is affected more, it is the responsibility of a human like us and the researchers to implement these concepts in order to save the nation. So, like we have got IBM Weather Company, which has implemented this AI and a weather forecaster, given the early warnings, and it has made more preparedness for the human beings, and they have reduced the damage. And we have got Pano AI. It is again an alert system for wildfire detection, which can be installed by the citizens of the area, those are nearest to that area. So a small wildfire will even alert them and they take necessary actions. Next, we have got Android earthquake alert systems, which alerts through smartphone accelerometer. And we have this here. And next, we have got crowdsourcing with AI. Excuse me, ma'am.
Yes,
Is my
ma'am.
voice audible? Yeah.
Yes, ma'am. Yes, ma'am.
Can I go ahead? Oh, okay. Okay. I could get a call from Miss Elizabeth. That's why I just want to have.
Sometime, ma'am, actually, it is little bit shivering is there, but now it's
Okay.
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 Ah,
Okay. Okay. Maybe the network issue might be.
yeah,
Okay.
yeah, maybe, ma'am. Okay.
Okay.
Ma'am, can I ask you one more thing?
Yeah. Yeah. Yes.
Have you joined? Is your mic and video from two different devices?
Yeah.
Because
Yeah. Yes. Yes, ma'am. Because I'm having. Can I switch off the video if it is not clear?
actually, we need the video since it is recording.
Okay.
So, can you join from a single device? Can you make the video also?
Because since the network issues, there will be issues. The voice may not be clear. That's why I've just made in a dual mode.
No, can you switch on the video also in the other system also? It's okay.
Okay,
Maybe you
then
have a problem.
let me check. Let me check.
Okay, ma'am. Okay, ma'am. Sure, ma'am. Thank you.
Is this okay? Hope this is okay.
Yes, ma'am.
Just rotate,
Just rotate it. Just
rotate,
rotate.
ma'am, rotate.
Okay.
Yeah, yes, ma'am, it's correct now. It's correct now.
Oh,
Yes.
okay.
A bit more. Can you move it a bit more to your right, the screen? A bit more. Correct, correct. That will do, ma'am. That will do. A bit to your left. A bit, just a bit, ma'am, to your left. Okay. Okay, that's it.
That okay? Oh, fine.
Okay, ma'am.
So these were the case studies we have been talking about, which is not, unfortunately, it's not from India. So we have got that from various countries. And next, when we come to the ethical challenges, it's the data availability because it's going to be a vast data that is needed in order to accurately measure it. And it is diverse data sets also. It is not from a single source. We may require it from multiple sources. So the challenges is we have to bias in AI models to ensure the fairness in resource allocation and decision making. Coming to the integration with the existing system, we have to check whether the existing system helps supports the disaster management framework. And moreover, we need the trust and acceptance in order to build this AI driven solution because we don't have the proper proof because which that situation at the time of disaster we may be finding it is be very sensitive, so we have to be carefully handle this. And coming to the cyber security part, we have to protect the data and which should not be handled mishandled. So data privacy and security accountable for AI decisions and should be ensured. Coming to the future trends and innovations, we may go for explainable AI to make AI decisions to be transparent and understandable. We may require edge AI and IoT integrations because we mostly use smart sensors in real-time processing. So robots and drones with AI automate may require. So where it is not reachable for the victims, we have to move with drones. So in autonomous inspections and delivery is important. Next, we have got the concepts of generative AI, which should help us to respond the plan and simulation. So we have got AI-powered digital twins. This is what I was talking about. So this is a virtual model which will create and plan or predict how the loss of the predictions of how the law damage would be after the disaster. So it does not happen after the disaster. It just predicts before, well in advance, what will be the damage, level of damage in case of disaster. So it like helps us to make the resource allocation, assess damage assessments and recovery planning. And next we have got human AI collaborations where we augmenting the human capabilities. It is not to replace humans, it is just to replace the repeated tasks that a human being is required, which a human cannot work for a 24/7. So this is the major gaps that we could see in post-disaster management. So first we'll talk about the generalization across the disasters. So when we talk about the generalization across disaster types and regions, the disaster type may vary and also it is change depends upon the region. So the depth of the disaster may change. So most of the AI models are trained on limited data sets. So they fail when we apply for a new concept of disaster. So the gap is we have to check the domain adaptation and universal models for this diverse geographic and hazards. So this is the first research gap that it's a very challenging gap where we have to check the AI model has to design in a such a way that it is works well for a new this type of disaster. Next, we have got multimodal and real-time data integration. As you know, the data we have got different vast of data in, and this data has to be handled. So we may receive data from imaginary like satellites, IoT sensors, even social media. So each will give you a partial information. So based on this information, a system should work effectively to get a real-time handling a real-time situation. So we need a multimodal fusion framework that could handle the incomplete and noisy and asynchronous data streams. And we have also have the third gap as uncertainty in quantification and trust. So most of the AI outputs are point predictions, like yes, no, or like minimal. But the emergency responders needs a confidence score and reliability estimations for this explainable reasons. So we are very uncertain about the unpredictability of AI models for critical decision making. And next we have got label scarcity and noisy annotations. Disaster data sets are very expensive and slow to label. Even existing ones has got ambiguous and inconsistent data labels. So a supervised or a self-supervised or a deep learning approaches may not be evolving, it will be not effectively evolved for this disasters. So that is the main challenge we have got. And next, from the detection to actionable decision supports. So we have to see the damage classifications, what is the depth of damage, what is the need end need for the victims, and it has to be translated into resource plans, and necessary decisions has to be taken. So end-to-end decision support systems like prediction action, predictable actions is very important, which it is not, so far it has not been done. Next, we have got post-disaster cascading effects. So it is not only the disasters, it may also, we need to also focus the immediate damages or the secondary damages, that is maybe the earthquakes. We can't say that only once the earthquake comes. The frequency of earthquake may be, if it is severe, you may get the tremendous and the effects even in the near future. So we have to see the after effects of all the post-disaster techniques. And next we have got social media data, which is, we have got noise as well as value. As you know, social media has got a lot of data, but most of them are noisy, multilingual, and prone to misinformation. So the researchers has to get into it, and NLP plays an important role in filtering the misinformations and localizing the context and support lower resource languages. And next we have got ethical privacy and equity. In this, we have got the location of disaster may vary, depends upon the place to place and country. So the AI-driven resource allocation should be fair enough in order to accommodate the in a poor rural region also. So the ethical framework and the privacy preserving AI, like federated learning, should be able to handle the different types of disasters based on the context of the disaster. And next, coming to human AI collaboration, this AI tools has to be built to be very trustworthy, and it has to be integrated into emergency workflows. So wherever the humans are not reachable, the robots or the drones should help them, and it should act immediately in order to respond to the responders. So it is a very important for the agencies or the rescuing team to depend on this AI. So the collaboration between the human and AI is very necessary. Next, we have got lack of standardization benchmarks and field validations. So many methods are tested only on academic data sets, which is not really operational scenarios. So when we come to this post-disaster management, we have to work on this generalized, open, and we have to have open benchmarks, and we have to have a real-time pilot deployments to test. So we have to have a continuous monitoring of the climate, and we have to do it, and we have to standardize a benchmark for this. So when we talk about the pre-disaster phases, so before in concluding, I just want to talk about the disaster assessments and predictions. So we will talk about the pre-disaster phase. Machine learning and deep learning plays a vital role in predicting the floods, cyclones, or droughts or earthquakes using historical data. So we need LSTMs networks for time series forecasting. And next, we need a remote sensing and satellite data analysis, like one to identify the wildfire hotspots and flood-prone zones. And next, we need a digital twins, like replicating the virtual infrastructure and to assess the damage and impact and its vulnerabilities. So we need a climate modeling with AI. So this will help us to monitor the climate and assess and predict the vulnerabilities of that particular area. Next, we have got early warning and detection, that is about predictions. So we may require like a Pano AI or Alert California like applications, which uses a computer visions with live cameras to feed on the drone images after disasters. And also we have crowdsourcing on AI, where Android earthquake alert systems may help us to identify the earthquakes and severities. And we IoT and sensor networks, which helps us to know the level of flood, air quality, and the landslide risk that happens within the area. And or moreover, we require natural language processing NLPs in order to analyze the social media posts for real-time disaster signals. And coming to the rescue and emergency responses, we need robots and autonomous drones, where AI-powered drones for searching surveyors who are under debris. They may be alive or dead. So it is quick drones, which could be with a LIDAR in order to locate the victims in a collapsed structure is very much essential. So robots and autonomous drones are very essential. And next, when we talk about thermal imaging and thermal scanning, so when a particular people are buried underground, the thermal scanners are very much essential in order to identify whether the human being is alive or dead with their heat signatures. And when we talk about the resource allocation, we have to optimize the algorithm for ambulance routing, relief of support, supply and distribution of, and also the shelter allocation. So it has to be all planned well in advance so that based on the area of disaster, it has to be rerouted in order to optimize with the immediate reach of ambulance and supply of food and other distributions. So we also require some conventional AI charts in order to evacuate immediately the victims after disaster. So these are the rescues and emergency responses that an AI should accelerate in order to search and rescue and relief operations. Next, when we talk about AI is in damage assessment and recovery. So AI should help to evaluate the destruction and plan out to reconstruct the disasters. So we may have image recognition, either a satellite or drone images. So we may be able to assess the infrastructure damages or crop loss or urban destructions. So this has to be identified and has to make the damage assessments. And also have to have a predictive analytics to estimate the economic loss that could happen if the disaster is happening. So we have to prioritize the recovery, and also we have to identify the economic losses also. And then next we talk about the digital twin based on damages. So it's very unconcerned when a building gets collapsed or an infrastructure gets disturbed. We have to estimate its cost of damages.
Excuse
So
me, ma'am.
damage assess. Yes.
Excuse me, ma'am. Ma'am, your slide, your presentation, actually, we are in the research gap slide, ma'am. Can you
Yeah,
please
okay.
put the
So yes, it's all in the where we've been talking about this damage assessments and recovery in the research gaps, ma'am.
Okay, okay.
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 Because we have just formulated only the points. Now I'm just having a detailed of this.
Okay, ma'am.
Next stage is the resilience and preparedness, that is post-disaster long-term phase. So only once in the day of the disaster or the 1 2 weeks of disaster might not be. We have to prepare well for a long-term phase. So we have the support like big data analytics and is very important in turn analyzing the long-term analysis of the disaster trends, which these are found to be very highly uh, demanding. When we compare to this economic losses for a country, it is very essential to set up this big data analytics like servers and very high end servers in order to monitoring the climate and also to predict the data or simulate prepare for a simulation of a scenario planning is very essential. So rather than getting the loss through economic loss through after disaster is better. We plan ahead and we set up a good infrastructure in order to prevent this and handle the post disasters. So moreover, we need a community centric AI systems where the public should be given the awareness about the risk of a risk, and it has to be communicated and it has to be educated to all the areas which are prone for disasters. So these concepts can be integrated with smart cities so that this helps us in urban planning. And also, when we talk about Chennai, we used to always talk about Chennai flood. So this flood drainage and earthquake, these all has to be planned along with the urban planning, which when we talk about smart cities. So these are the areas where AI has a vital role and it has got a lot of opportunities in this post-disaster management. So we have got a plan and we have also submitted a project where we are planning for a climate analysis. So we monitor the climate with the sensors and also the satellite images, which is very high. Huge data is included. So we are just planning it within our area and we are working on this project on climate monitoring. On all of capturing all this data, we could help us to recover it and or predict the disasters that may happen in the future. And also some enabling technologies that will help us in this post-disaster management or so there's a lot of opportunities for the participants. If you're trying to do your research, you've got a lot of opportunities in identifying the predictions and classification algorithms in machine learning and deep learning models. And when those who are interested in computer visions, you can go for video audio analytics of the damages of fire or smoke detections. And some may be interested in natural language processing. You may process some emergency text and social media data and news. And when we call some those are participants, those are interested in internet of things, you can use smart sensors for real-time monitoring and earthquake to identify the earthquake data or a flood or a landslide data. And those are interested in robotics, like those are in mechatronics or in some other area. You can search for a rescue mission planning and mapping the affected area. And those are interested in AR, VR, you can go for a model like virtual model for simulation and damage assessments, where those are working on cloud and edge. You can work on real-time processing for vast disaster data. And finally, we have got a big data analytics, which can handle a heterogeneous of data sets from satellites and sensors and social medias. So these are the areas where you can work on. There is a lot of opportunities to work. So I could put in simple terms like you can work on this post disaster management. There's a lot of opportunities seeking for you, and you can work on these opportunities in order to complete your research, which would also be a social cause also. And the key takeaways of this is that you have got an unpredictable opportunities to enhance the post-disaster management, and you have got rapid assessments and optimized recovery and AI streamlines. And we have got more of ethical challenges. Those who are interested in security, you can also derive more ethical challenges in AI security in preserving the data privacy, and this and continuous innovation and collaborative key for the human community. So we have got to invest more AI research and development on this area in order to foster the collaboration between the AI experts and human organizations, where we have to minimize the economic loss of a country for the better development of a country. So do you have any queries? Regarding case study, let's move on to case study if you've got any queries. So these are some research gaps I could identify for you. So the participants, those are interested in doing research. And also, it is not only those who are doing research, you can also try to submit the proposals on this post-disaster management. That is a vast opportunities where it is very essential for India to work on this area. So even you can submit some project proposals on this area. I would like to hear if you have got any queries.
So participants, if you have any queries, you can place it in the chat box also.
So there's a lot of opportunities. I could request you all to just note it off, and you can think it over while you're submitting your proposals for your college. So there's a lot of proposals coming up from DST, ARPN, and so in all the projects. You can take one of this as a key takeaway, and you can try to implement, try to submit a proposal on this. So there's a lot of research gaps that has to be analyzed in post-disaster techniques. So I have submitted a proposal on climate monitoring, where we used to get the data because it's very essential for us to get the data, because the availability of data is very crucial and it's also vast. So we are just submitted a proposal over the climate monitoring, and we are just waiting for that. And moreover, then we have got one more project where we use this radar, micro Doppler signals along with the drones in order to identify the victims, those are alive or dead. So it is an automatic detection of surveyors using UAV drones where it is not able to reach human beings in the disaster area. So in order to, which is not easy accessible, we try to design a drones which would carry a thermal scanner which could identify the human beings who are buried underground with the door signals like LIDAR so that it could identify whether the person is alive or dead under the debris. And next, other than this, you have got additionally a health and disease monitoring AI for this model, where the victims, those are affected, may have some health or mental disaster or disorder because they have been affected more. So we may request them victims has to have a wearable and IoT devices where AI plays an important role in monitoring the health and also their mood swings. The past 3 days, I could see, I was also one of the participants for this FDP. I was just going through this, all the technical talks that has been given by different resource persons, and every technology has been given as your awareness for you. And we have to integrate all these concepts in order to get an product out of this FDP. So this mood swings, yesterday we were been talking about identification of a human mood, whether it's happy or sad. Similarly, the wearable devices will help the victims to identify how the mental stresses, how they mentally affected. The victims will be always in a mental pressure once when they are exposed to the disaster. And also the NLP will help them to analyze the social media and health emergencies and medical shortages that are essential in that area. And moreover, the psychological and social support is very much required, where NLP will chatbots with NLP will help them to provide a 24/7 for this disaster surveyors. So we also use sentimental analysis in order to manage this data in a social media and to understand the community, the stress, the panic, and the urgent needs what the particular area is facing up. And also we need a rich decision support systems where we need expert systems to authorize and the recovery task. So the dashboards, in order to manage what is the actual seismic, in case of earthquake, we must know what is the seismic frequencies and what is the actionable activities that has to be carried out with this decision support. And also we have to see the infrastructure and resource planning. So whenever we set up a city, the AI should rebuild all the designs and recommended the cities in order to avoid the disasters and how to manage in case of disasters. So a big data and machine learning plays a vital role in order to predict future disasters and guide them how to recover from these disasters. So it is very essential for all AI techniques comes into play when we talk about this post-disaster management. It is not just a theoretical topic alone. When we talk or just a disaster management, it is just only not the post-disasters that we handle at the time of disaster. It has to be mitigated and planned and prepared well in advance in order to face all the post-disaster managements. So these are my key takeaways that has to be considered. So if there is no queries, let's move on to the case study, how it's happened and what are the case, how it is, AI has played an important role in prevention of some disasters. In case of Android, just we'll move on to the case study slides. So when we talk about IBM, so this IBM case study, there was a weather company from an IBM business. Okay, it is based on the big data analytics, which was helping us to provide the forecast and clear warnings to save lives of economical losses. So it has proved heavily when it was an extreme weather climate has done, like hurricanes and flood and heat waves and wildfires have increased its frequency and intensity in US. So this was the case study that has been taken, and IBM AI, the weather company, has given a solution for this, and it has greatly minimized the economic losses. And next case study is Pano AI and Alert California. So this was the case study which was used for early detection of wildfire. So each and every citizen who's exposed that in particular area of wildfire has been given an app or an alert system for reducing the massive loss of life, because wildfire, it will be capturing the fire will capture quickly, so it is very unpredictable to identify it. So it is very helpful for the wildfire to identify the wildfire. So the delaying may have the delaying of handling this wildfire may have a huge damage. So this AI model has helped us to slow down uh, economic losses, as well as the cameras that are being installed in the normal mobile phones has helped us for an AI driven camera systems and real time data analytics to detect the wildfires at the earliest stages itself. And it is at the earliest stage, the Pano AI and Alert California helps to detect the wildfire as early as possible. Next is your Android earthquake alert system. So as you know, earthquake, we have to measure the seismic waves. The earthquake, the tremendous of earthquake may spread. If it is happening under the sea, it may go for a global destruction. So this Android earthquake alert system is AI powered, for early warnings. So you would have heard just a few months before, Japan had an earthquake under the sea. So even there was no loss of humans because they were detected earlier and the alert was given to the people. So they were evacuated all the people around that area, and there was no loss or minimal loss of a human being in Japan. So this Android earthquake alert system has really proved that the traditional seismic graph it is based on this traditional seismic graph, which gives an early warning, and it is very expensive and centralized and limited to specific regions alone. So this earthquake alert system it was developed by Google, was helping much of the country's economic loss. And finally, we have got crowdsourcing with AI apps, which we called as no burn. That's again regarding this bushfire prevention. So this bushfire is mostly a threatening one in Australia, California, and South Europe. So due to the dry conditions and climatic changes in that countries, the increase in fire risk is happening. So the traditional detection systems rely only on satellite monitoring and fire services, which is very slow and which is not active in emergency cases. So in order to address this, they started to use an AI powered mobile application like No Burn, which we call it as No Burn, which will allow the citizens which acts as a sensors for the citizens, and they could finally relate the observation. They could early detect this bush fire, and they were prevented by taking the necessary steps and alert the nearest fire stations like that. So these are the major 4 case studies that have been which has been implementing this AI techniques and had proven that can prevent the loss for the country. So unfortunately, we don't have such system in India in order to prevent the landslide or earthquake or any tsunami alert so far. So it's unfortunate, and as academicians and researchers, I request you to contribute on this different task, and so that we can help the nation with the for the reduced economical loss. Any queries so far? Participants, do you have any queries? So Google has got more on this AI model leveraging for real-time disaster information disseminations. So Google is working more on this. So more search algorithms and data partnershiping is for to provide the real-time and disaster updates. It's working on in a huge area. So you can just type it on Google Crisis Response Team, leveraging AI for real-time disaster information dissemination, so that you get more of your AI techniques that is necessary for this responses. So really, it is real-time life-saving information, so because it includes millions of people receiving the timely alerts during flood, so which will help the casualties. So Google is working on this crisis response team. So we have got a lot of AI techniques and approaches: AI-powered information extraction, crisis mapping, public alerting, early warning and forecast systems, and user-centric informations and disseminations, and also data privacy and security. More because we can, citizens should not be given with a false data. So the data security and privacy also plays a vital role in verifying the disaster updates. So a delay or misleading information should not also reach the citizens. So it is very unpractical that we have to work on this area. So the real-time shelter location is very much needed for any disasters like earthquakes or pandemics which affect the AA country. So do you have any doubts in this, like challenges and ethical considerations? I think thank the organizing teams for giving an opportunity to present on this post disaster management. I've shared my mail ID and mobile number. So those who are interested, please contact me so that I could help you.
Okay, ma'am. Okay. Dear participants, if there is any queries, you can ask now.
Since this is not so more technical, the time was just limited. It is more of technical, it will be taken along.
Okay.
When Ms. Elizabeth contacted me, she was talking about that you just want to deliver on post disaster. So since I was working on this area, I was very
Okay.
much welcome to and accepted her thing, and I just immediately said yes, I will do
Yes.
on this.
Ma'am, what about the funding and all, ma'am, for these types of projects? Because it will be helping the government also, isn't it?
Yes, it is very essential. It'll be around the funding will be above of 1.5 crores. Minimum you need 1.5 crores because you need a lot of data servers and high-end servers,
Yes, ma'am.
So, and also cloud technology, so that anyway, the minimum of 1.5 crores you may require this fund. But now we are just doing within our institution level. We are just having small sensors and just monitoring the climate alone. And we have just submitted a proposal to ARNF for the total climate monitoring using community engagement, where we need the people of that particular area to be aware, and they have to engage for the disaster. Total awareness about the climate. So it is
Yes,
not the one man can do this. Because the total community has to be engaged totally in order to have this climate monitoring, entire climate monitoring and management, and their post management techniques, which is very important. It depends upon region to region. It is not that one region may require different type of requirements, where the other region may require. Say, for example, in a hilly area, hill stations, which are prone to landslides. So we have to have a technique in such a way that the communities totally should be engaged in order to prevent that such landslides. Because this is where the community engagement is very important, because the affected victims are those communities. So which the climate monitoring, every alert system has to be given to that particular community. So since it depends upon the area to area, it is a little bit challenging. So we can't put together all the disaster into the same technique. Earthquake may have different effect, whereas landslide will have some other different. Flood may have different effect. Sometimes flood along with the landslide may have a different effect. So this is very challenging area where we have to work more and we have to focus more. And there is a
Ma'am,
lot of opportunities for us to have in the proposals. There is a lot of opportunities. You can submit more proposals on this.
okay, ma'am, what about the sensors, the cost of sensors, how it is placed? Can you explain more?
Pardon, sensors. Do you say sensors?
Yeah, to identify the disaster or calamities,
Yeah.
how it is placed and how it will be operated.
Yeah, it's just a same thermal sensors which with the high-end data. Okay, it's on wireless networks. Yesterday we were talking about this in the yesterday's session. So all the sensor, uh, when you have to first identify the region which is very prone. It has been done only on monitoring a particular area for more than 10 years. So each and every day-to-day data has to be observed, and it has to be modeled in order to predict that what will happen next. Say, for example, it's not thought going to be rain all the 365 days. So we have each area has got different climatical conditions and climatical changes. So which has to be first observed with the sensor data, which we have to place in the particular area. And also we have to monitor along with the satellite images also. So satellite images also plays a vital role. So there is not a single sensor data, or IoT is not only going to give you the input. It is more the satellite images as well as the sensor data. That sensors may be placed on the ground, or some sensors has to be dig underground and has to be placed in order to get the temperature assessments. So, and also when you're talking about a flood, it has some sensors has to be identified for, like for rain, prediction of rain. What we have now. So we have some sensors to predict the rain. Similarly, we have to predict earthquake, heat waves, everything. We have to predict the climatic conditions in order to set up initially and to monitor what will be the cause of this particular climate. Say, for example, tomorrow it's going to be more than 45 degrees C. What is the necessary action to be taken? So why the climate is getting worse every day? What is that? It should be a picturized from the past 30 years of data, which was very essential. So every day data is very essential, and every minute data is very essential in order to predict the future.
Okay, can you explain any procedure that is already completed in your area? Like,
That's what we have got the rain prediction where we predict whether there'll be a rain in upcoming days, and what will be the temperature. And also you have got more of this air indexing systems, where what is the quality of air, what is the how or the pollution. Many sensors are there in order to identify the pollution content. What is the content is, what is the carbon level, what is the nitrogen level, and we have got different sensors. So all these sensors has to be put together, and in order to analyze this, it's not only one sensor is not going to help you. There's multiple sensors comes into play, and you have to analyze all this data. So we have got we have done rainfall predictions and weather predictions alone so far, and we are just working on this air quality prediction.
ma'am, what is the lifetime of a sensor? Like, it can be used for decades, or it is any duration for that sensors?
So
Lifetime.
usually the sensors will not have long last for lasting years. So it will be every 2 years we have to replace it, because it's been actively working. Every day it has to send the signals. So maximum it will be for 1 or 2 years. If it's a very high quality, it has to be replaced. And as you know, we have got IoTs and vehicle IoTs. So even that, if the data from that different vehicles also can help us in identifying the sensors. So mostly the sensors will last for maximum of 2 years, not more than that. But it's very of high quality, it may. So it has to be replaced, and it also we need smart sensors which has to be actively changed.
So
It
the
depends. If
sensor,
sensors are
the
of very high quality, then it will be because we have used only reasonable price sensors.
okay, the sensors working using solar power or any other power like electricity?
No, it's going to be a wireless sensor, so it has got its own battery and also solar. Mostly the preference when you are going to set up in a real time, mostly we have to work with the solar. That is the better option. But some places where there is no chance of solar, we have to use the battery. Say, for example, some sensors has to be buried underground in order to get some identification, like sesamic, which is under the water, even under the water. In that case, it has got to be worked with some other sources of energy is essential. It is not, we can't depend totally on a solar sensor. Some electric, even if you are going to set up, if there is going to be a prone area of earthquake under the water, under sea, then they have to have a separate type of a small setup below the earth, in order to get below the water, under the surface of water, in order to monitor it continuously. It depends upon the area and what the application we are using that sensor is.
Okay, ma'am. Thank you.
Thank you, Mr. Sheikh.
One more doubt, ma'am. Can we get any data from IMD about the weather change, the forecasting in IMD, the Indian Meteorology Department? They will be having more.
More
information,
yes,
isn't it?
more information, but once you're going under and the government approved projects, you may get that data. And so far, I have not got it. Actually, I just tried with one of the scientists who was working in ISRO. I just tried to want to get a geospatial data for the analyzing the space, like damages assessment, what we have been talking about, the digital twinning. What is the before, what will be the part of damage after the disaster is happening. But unfortunately, I was not able to get more than that, because that is all data privacy. As an academician, we are not able to reach such data sets. So mostly we are
Okay.
talking on only theoretical part, but we can
Yes,
just
yes,
have
yes.
a small thing which we can develop in our area, which would help us, our community alone. We can't go for a national wide data set,
Okay, okay.
which is again the data privacy and security again.
Yes, yes,
Since
yes.
it's got, and if you are working with some team like Google or that, they've got the privacy and they got necessary security for them to access. But unfortunately, we have a limited access. That's what.
Okay, okay.
That's why we have to do we have to submit a proposals through government. We'll be able to get the data.
Yeah, that is a good.
And
Well,
then also,
because
moreover, as we are in for a private institution, it is unable to. It will be very high time for us to reach that level. If it is in like NIT, IIT, they would have got a more scope of getting the data.
okay.
Ma'am, what are the
And this,
opportunity for computer students in this area, like in disaster management
so the Lord,
opportunities?
that's what we have been talking on AI techniques. So more of AI, like you can develop more of machine. Now all the youngsters are very much interested only on machine learning techniques. Not only the machine learning, we have got a lot of tech, like edge computing, cloud computing also plays a vital role. It is not only the machine learning is essential for this post disaster management. More technology is, from computer science, like computer visions for analyzing the image and video analytics, NLPs, natural language processings, and IoT sensors, what we are talking. And moreover, the drones, if the students are interested in designing drones and smart sensors which can be embedded in the drones, and the drones can have this helps to rescue the missions, and more of big or receiving all the data and manipulating with the big data analytics. So there's a lot of opportunities for a computer science students to do research in this area. As to totally, we can't say that post disaster management is a very huge area, but the students can take one single application and they can work on it. Mostly try to motivate the students to go with the community, or what is the problem in the community area. Say for example, some nearby area will have more of pollution control. So the awareness of the pollution, you can just assess the pollution of your nearest community, and you can give the awareness for that. Even that plays a small important role for the community. So students can take such simple projects in order to identify what is the level of air quality, what is the if they're going burning the waste. So what is the air, how the air is getting polluted. These all can be identified by the students, which are the simple projects which can be carried out by the students quickly. And even if they are interested in image and even the dustbin, you have heard, I think so. The dustbin can segregate the plastic waste and biodegradable waste. And small projects, which this all the projects can help the students. Even the students can submit such projects to the government. Even Smart India Hackathon statements may have that, and also some governments are taking up initiatives and they are encouraging the students to submit the project proposals. So even the students can take up small projects of this disaster management, and they can handle this. They need not do all the entire thing. They can take a small part of it. Those who are interested in AR, VR can just design and show how the smart city would be on planning. Even that project is also helpful for the students.
Okay, ma'am. Okay, ma'am. Is there any query? There is no query, means we can wind up the session.
Okay.
Dear participants,
Please note down my mail and mobile so that you can reach me if you have got any doubts.
okay.
I thank once again the coordinator, Dr. Thomas, the co-coordinator, Mr. Sherin Panikar, and organizing members, Ms. Elizabeth, Mr. Sherin Matthew, and all the committee members for organizing such an event in a professional way. I really congratulate. I'm being a participant for the past 4 days, so I really enjoyed your organizing, even the way you organize the event in a professional way. I really thank everyone and also the total team for organizing it. Thank you so much.
Thank you, ma'am.
Thank you, ma'am. Thank you very much. Thank you.
Thanks a lot for the informative session, ma'am. Now I
Thank you
would
so
like
much.
to invite Ms. Sido Kurian, Assistant Professor, Department of Computer Science, for the vote of thanks. Sido, Miss.
Good evening to all. It gives me a great pleasure to deliver the vote of thanks for today's faculty development program, section on post-disaster management using AI techniques. First and foremost, I would like to extend our heartfelt thanks to Dr. Subarani Ma'am to delivering such an insightful section. The presentation shows how modern AI tools can play a vital role in disaster response and recovery, and it has truly enriched our understanding. The section has not only expanded our understanding of how AI can handle disaster management, but also inspired us to think about interdisciplinary applications and research collaboration in this crucial field. Your presentation has been both informative and covering wide spectrum of topics. Thanks to all the participants of your active involvement and attention throughout the section. Thank you all once again.
Thank you, Ms. Sido. Thank you.
Thank you so much,
Thank you.
participants, for your
Thank you.
valuable feedbacks. Thank you so much.
Thank you.
Thank you,
Thank you.
everyone. Thank you, everyone.
Thank you,
Thank
ma'am.
you, ma'am.
Thank you for
Thank you.
joining. Thank you.
Shailja Miss, I think Jindo sir is already joined.
Okay.
We can start.
Yes. Now moving on to the next session on data-driven decision making in healthcare using AI and innovative statistical methods. May I invite Ms. Deepa Lisa-Alex, Assistant Professor, Department of Computer Science, for introducing and welcoming our speaker of the session, Dr. Jindo J. Potekal. Over to you, Ms. Deepa.
Good evening, everyone. As we continue with our faculty development program, it's my privilege to introduce our distinguished speaker of today's second session, Dr. Jindo J. Potekal. Dr. Jindo J. Potekal serves as a manager of statistics at GlaxoSmithKline, USA, where he acts as a subject matter expert in advanced statistical and machine learning methodologies applied to clinical trials. Prior to joining GSK, he held the position of Principal Statistical Scientist at Thermo Fisher Scientific, providing statistical expertise, process knowledge, and regulatory insights. He previously served as a mathematical statistician at the US Food and Drug Administration, where he contributed in advanced statistical theory, regulatory submissions, and clinical data analysis. Dr. Jindo J. Potekal has expertise in developing statistical analysis components of clinical documentation, including study protocols, statistical analysis plans, clinical study reports, and scientific publications. He holds both a Master of Science and a Doctor of Philosophy in Statistics from the University of Maryland, USA. His research interests focus on Bayesian methods and machine learning applications in clinical research. Let us warmly welcome Dr. Jindo J. Potekal and invite him to take over the next session. Dr. Jindo J. Potekal, sir. Okay, so now it's time. Thank you.
Can you hear me all?
Yes, sir.
Okay. Yeah, thank you so much for the nice introduction and inviting me to this wonderful and thought-provoking faculty development program series. Let me share my screen. So today, my presentation is on data-driven decision-making in healthcare using AI and innovative statistical methods. So I'm planning to introduce, sometimes you may not have much experience or understanding on healthcare. So I'm planning to start from the basics and go to some advanced methods, both AI and statistical area. So this is my plan for today. So let me begin with a quote from Napoleon Bonaparte. He said, war is about 90% information. So sometimes we may think that war is about the army, the size of the army, the strength, or the equipments they have. But he actually in the 18th century, he predicted or he said that it is about information, which we are seeing right now, especially in the case of Ukraine and Russia. So they started the started war about 4 years back, but still it's ongoing. So compared to Ukraine, Russia is the superpower, but they were not able to advance as they thought of. So the thing is that sometimes they miscalculated or how they process the information that may affected their advancement. So the essence is that it is information, how we collect the information, how we process the information. So how large is the data right now? So approximately 402 million terabytes of data are created each day. That's a huge amount. And about 120 zettabytes generated in 2023 and are expected to increase by over 150% in 2025. 1 zettabyte is equal to about 1 trillion gigabytes. So this is the vast amount of data that's being created every day. So what's happening in a minute? In a minute, 16 million texts are being sent, and 5.9 million Google searches happening, about 231 million emails sent, 500 hours of YouTube videos got uploaded, and about 184,000 hours spent in Zoom meeting alone. So that is like there are other platforms. So how vast, how wide, how big is the data generating every day or every minute? So the problem here is that even if we have all this data, so how we process the data is very important, and those entities which holds the data has the power. So that's what Yuval Noah Harari, sometimes you may familiar, this name is very familiar, especially in the AI field. So he said, like, in the age of AI, the most valuable commodity will be data, and those who control it will hold enormous power. That we know. So that's why people are behind the data, collecting, accumulating the data. So those entities or countries or companies having maximum amount of data, they have enormous power. But the problem here is that our goal is to turn this data into information. So it doesn't matter how large data we have, but how can we turn this data into information and information insight? So deriving insights from the data, the big data is actually the main challenge nowadays. Another issue is that we are being bombarded with a lot of information, but we may not know like what exactly the truth or the truth, extracting truth from this vast amount of data or information is the real challenge. You might have seen like during election time, especially in the US election, it was reported that some boards actually intervened in the election process, and it spread misinformation that created bias. And these all things are there. So the data is there, but extracting data or getting meaningful insights from the data is very crucial. So this is actually the reality, in the sense like we have a lot of data, very chaotic, very clumsy data, but how to generate a meaningful, nice and meaningful output from that. That is the challenge. Like earlier, we didn't have this kind of big data. When I remember maybe 25 years back when I studied MSc Statistics in Nirmala College, actually we used a hand calculator to compute or in the statistical analysis. So at that time, the data set means about 100 subjects, but now we know that every day data is being accumulated. And another thing is that today is my presentation. I am focusing on how to use the historical data that is available. It may not be nice and clean, but how to get all this information into place. So this is the challenge for a statistician or a data scientist to get a meaningful insights from this large chunk of data. So it starts from the visualization, how to visualize the data. That's the first step maybe for a statistician. We try to visualize the data. How can we plot, or how can we visually interpret data? Any trends are there in the data. That's what the first thing that we look into the data. So here is a nice presentation, like how this is a scatter plot, where in the x-axis weight that is in pounds and height in inches on y-axis. So we can see that when the weight increases, height also increases. So this is actually, we can easily say that there could be some kind of a correlation happening between height and weight. As height increases, weight also increases, vice versa. And since when you can add a color onto that, one more layer onto that, that is, if I want to include a male or female. So female represents blue and male represent red. So you can see that. So let me take that is a point. So you can see that the male population actually occupy in the upper quadrant of the graph, and the female towards the lower quadrant. So this is kind of adding more layers into data visualization, and this actually tells a story about data, what's actually going on there. And this is very famous plot or graph from again from the Napoleon's time, as 19th century plot. That's considered one of the earliest nicely presented graphical representation. Actually, what it is, that it is the Napoleon's advancement to Moscow. That's happened in 1812. So this plot actually has 6 elements in this single plot. This is called the Minard's visualization of Napoleon's march. So here, the route actually is visualized here with a brown color. Then he advanced to Moscow. Then he decided to return. This is the black, actually represents his return route. And the width of the graph actually says how much army, how many people were there at the time when he started his military exploration. So he started with almost 422,000, almost 4 lakhs army men. Then he advanced, and on the course of time he lost people. That's why the width actually reduced. And when he reached in Moscow, it was almost 100,000. So he lost almost 300,000 people, 3 lakhs people on the way. And so he decided it's not possible to advance to Moscow. So he decided to retreat back to the base. So he again traveled all the way to back. Then in the course of time, he lost again people. And when he returned, it was about 10,000 people. So the rest of the people actually lost during this journey. So this is actually in this map, there are different other components. The distance is plotted here. The temperature is here. You can see the temperature. So temperature minus 26 and minus 21. So you can see that when the temperature drops, there is a significant drop in the army size. So and the longitude and latitude are also plotted here. Then direction of travel, location related to specific dates. All these included, almost 6 components are included in one single graph. So this is the way actually the new, especially if you use R and Python, like we can add more layers. Especially in R, we have ggplot and the grammar of graphics. Actually, we can add more components to a single plot. That's then we can develop it to like make a appealing story out of the data. Okay, so when I speak about statistics, like and the data, so this person is very famous. He is the father of modern statistics. So he was a genius, and he actually created most of the foundations of modern statistical science. So he devised the likelihood, maximum likelihood estimation, and the testing of hypothesis. All these fundamental things that we are using in AI also, like he was instrumental on that. And for his life, like this is very famous experiment that happened during his lifetime. That is, on one evening, one lady actually claimed that she has the power to distinguish whether milk was added to tea first or vice versa. So he actually wanted to test this claim. So he gave like almost 20 cups of tea to this lady and checked, and he devised a test called the Fisher's exact test on that. So actually he created almost all the foundations of modern statistical science. So so from there, like on this data and more data is coming up, and so how to derive meaningful information from the data, that was the challenge. And that actually ended up this artificial intelligence and using the data as the foundation of the machine learning and all. So how the statistics got like involved or evolved at the same time, the AI also like machine learning techniques also got evolved over a period of time. And statistics actually provided the core building blocks of AI, maybe like a logistic regression or predictive modeling or bootstraps. All these concepts are from the statistics. So the modern AI is based on probability theory for quantifying uncertainty, making data-based forecasts. So the interesting thing is that we may use different terminology in statistics and machine learning areas, but the basic concepts are the same. So Bayesian statistics are also very important in this area, and the regression methods, different regression methods. All these these are like the founder or the is based on the statistical principles. So I'm going to some details on the Bayesian statistics. In later slides. So what's artificial intelligence? We all discussed this. I'm not spending time here. So different kinds of learning. This is like a supervised learning, then unsupervised, semi-supervised learning, reinforcement. Or you may be familiar with all. I also attended previous seminars, so I know people address this. Maybe I can just give an example of supervised learning classification for in the clinical setting. So here an example of a supervised learning in the people with the heart disease. So the objective here is we need to predict whether a new subject is a potential heart patient. So that's the objective here. But we have the data from the previous studies, or we already have almost 10 subjects data. They have, like, we know their gender, family history, age, smoking habits. So the purple represent A's and blue no. So for the first subject is male, then no history, family history, then above 60, no, it's like under 60. Smoking is above 60 years, then smoking, no smoking, and he has heart disease. So likewise, we have this data, and our challenge or our objective is to predict a new subject comes, like with all these different combination, whether can we predict his potential chance of having a heart disease. So this is kind of in the clinical setting where we can apply this supervised learning method. So now I just go to a clinical development process to get an understanding what's actually going on in a clinical development process. So this is like a drug development cycle. So we know, like, we just go to the pharmacy and buy a drug, but we may not know it involves, like, once to get that drug in the pharmacy, reach the pharmacy, it takes several years of experiments and studies and all these things involved before a drug got approved. So for a drug got approved, especially in the US or like in the Western countries, total investment could be 1.5 to $2 billion. So that's a huge amount of investment is needed. And there are different phases. In the preclinical phases, about 30% of investment is there. Clinical trials, 50%. Regulatory phase is 20%. So the life cycle is like this. So about 5,000 to 10,000 compounds will be tested initially to make a drug. So out of that, in the preclinical phase, it would reduce to 5 components. By the time, it may take 5 years to get those 5 compounds, which has a potential impact or efficacy. So this 5,000 to 10,000 distills down to 5 compounds. And in the first, like a phase one is this compound will be tested on 20 to 100 subjects. So that's a phase 1 study. In the phase 2, this is like more towards the efficacy of the safety of the drug. In the phase 2, it's like in that study there will be 100 to 500 people in that phase. So once the study or the compound is safe, is being proved by the phase 1, then phase 2 will enter more towards the efficacy. And in the first phase also, the dose, what appropriate dose will be used, that would be find out. Then enter into the phase 3. That is where, in a large cohort, large number of patients, this compound got tested. And in this phase, actually, the study checking whether this drug has a real effect on human beings. So this compound, maybe 5 compounds, may reduce to maybe 1 drug at the end of this cycle. And it takes about 15 years to get this drug got approved. What I said this, like what I showed this graphical representation, is that nowadays AI comes into picture, and AI effectively reduce this cost and the duration of the trial. So that's a huge advancement, huge advantage for the entire humanity, where AI could actually improve the efficacy or and the duration of the trial. Thereby, we may able to get drugs approved sooner and with a cost-effective manner. And also, I will show how a typical randomized clinical trials work. So randomized clinical trials is the gold standard. How this work is that we have initial group of patients, and this group will be randomized to 2 groups typically. A treatment group and a control group. In the treatment group, we give the medicine, the drug, and the control group, we give a drug-like substance which is called placebo. It doesn't have any effect, but to make so in every aspect, the placebo resembles the treatment. So this is to avoid any kind of bias. So there will be a treatment period, and there will be a follow-up period, maybe 24 weeks or like 1 year. Then we compare the results between these 2 groups. This is how a typical drug development or clinical trial works. So, as I said before, in this course of this drug development process, a lot of innovative AI applications are being introduced. So starting from medical diagnosis and treatment. So nowadays, AI applications are there to diagnose the disease more early and suggest treatments. So, and also drug discovery and vaccine research. So in drug discovery, as you said, initially there were multiple compounds. So AI algorithms can actually help there to use the historical data and and or available data and have like ML models for the drug discovery. Another one is patient data processing. So identifying suitable patient group is very important. So we have like different patient characteristics. So based on the patient characteristics, how we can recruit the optimal or best patients. So that's very, for a human, screening is very challenging, but AI could do that in better way. And medical imaging analysis, this is very huge application, especially like the reading scans and all. We may familiar like deep Google project on like a retinal scan. So this could replace optometrist. So the AI can read these images and recommend the treatments. And electronic health records, that's a big area because these records are very huge and humanly very tedious task to maintain these records. And here also AI applications are there. And another one is remote patient assistance or virtual assistance chatbots. And this is also very important because nowadays, so especially people who are living isolated or without having proper assistance. So the AI virtual assistants are there to support them. And you may know the robotic surgery and precision medicine. Precision medicine is very a new development. It's like nowadays the medicines are like are administered in a group setting, like it's in a general fashion. But in a precision medicine, so the dosage and everything can determined for a particular individual. So the ML applications can use these models can like recommend the medicines like precisely for a single individual instead of like a group trial. So this is also an interesting application. So some more application, to be more like more specific, AlphaFold 2 is an AI application. So that's used for protein structure prediction. So this predicts a protein's 3D structure from its amino acid sequence, and this actually improved the prediction speed up to 82%. So that's a considerable improvement. And in 2024, the people behind this application actually they received Nobel Prize for this their contribution in this area. And there is a trial GPT, and this actually helped to speed up the process by selecting patients for clinical trial. So this is also a very helpful tool, and it achieved 87.3 accuracy, and that actually matches with the expert levels. So there is room for improvement. So then eventually this could be replaced by human intervention. So this could like the AI could take over this area. And AI-powered adverse event detection system. That's a Bayer's one pharmaceutical companies like Bayer. They have developed this AI-powered adverse event. So in the course of a clinical trial, there are adverse events happens like death or any kind of adverse events. So this could be detected, early detected using AI system. And there is a Skin Vision app. It's reported that 95% of early detection rate of skin cancer by using this app. And there is another tool called clinical trial simulation. So that's actually helping to optimize clinical trial design using AI. So no need to wait till the end of the study or like patient recruitment. So we can simulate the trial, and we can see how the potential risk on this. And there is another Heidi Health. That is to automate medical note taking and transcription. So this is a huge area. Heidi Health is actually replacing or supporting these transcription services. So medical note taking and everything can be automated through this app. Another one is Google CoDoc. This is Google's product, actually AI model that learns when to trust a predictive AI diagnosis or defer to a clinician. So this model actually recommends recommends at what time it is appropriate to go to a clinician. So the one noticeable thing is that this model reduced number of false positives by 25%, but without missing any true positives. So that means this model didn't actually have any errors for the true cases. So false positives are there. That's okay. Like referring, that means referring a good person to a clinician, that could be okay. But this model did not miss any true positives. So it clearly or correctly differ patients with serious issues to clinician. So these are, there are like hundreds of similar AI tools just to outline what's actually happening there. Maybe as a computer scientist, like professors, you may interested in any of these areas. Maybe you can go further research in this. And an interesting thing is that in healthcare, it is very rapidly advancing area because of, as I showed before, the vast amount of investment and the duration. So anyway, if we can improve this development life cycle, that could save millions of people and save money, and the entire, we can have like a better place. Okay, from this, like I am just introducing another thing that are digital twins. It's another area where we the drug development life cycle could be reduced, or the number of samples required for a clinical trial could be reduced using digital twins. So digital twins are mathematical model with an updating mechanism that generates data which are indistinguishable from its physical counterpart. So that means like for a real physical entity, we can create a digital twin, digital pair of that, and we can, that is actually a mathematical model, and we can, that's kind of a two-way interaction. That means from the physical entity, we can use to derive the digital twin, and the digital twin can use for prediction as well. It could be cell, organ, or patient. So in clinical research, the digital twins, DTs, are a virtual representation of patients that resemble the longitudinal characteristics of actual patients. So here we can actually have like a digital twin that resembles the characteristic of a real patient. So that the good thing is that that this could substantially reduce the number of samples, number of subjects in a clinical trial. So this is has very application. So this is how these digital twins work. Like it's a step-by-step process. This is an outline of that. In the step one, use observed patient characteristics from external data sources. So these are the available data sources, the historical data. So we have obtained these characteristics from the historical data. And in the second step, train an ensemble of ML or statistical learning models on external data to predict outcome based on the standard of care. So as I said before, in the clinical trial, there are a treatment arm and a control arm. So we use the control arm for these digital twins. So we predict outcomes based on the standard of care or the control population from the historical data, and then apply these methods to baseline characteristic of a trial patient to create a personalized digital twin for each patient, predicting their likely outcome. So that means like we have a patients and we have active arm and standard of care. From the historical data, we use the ML methods and we obtain the digital twins for active arm and the digital twin here. So the advantage is that we may reduce the sample size. We don't need the entire sample, maybe half. The rest could be digital twins. So and how this works, integrate the digital twin prediction as a super covariate. So digital twin will be like, it aggregates the information from the historical data and make a kind of a single covariate. And we add that covariate to the model, the prognostic model. The treatment effect is there, other prognostic covariates are there, and the digital twin covariate we add to the model. That gives a new outcome for the new target population. So what's the advantage? The impact of trial design in terms of exceeded power gains, reduced sample size. So a statistical power is correctly rejecting the null hypothesis, or correctly saying that the drug is effective. So here it is 5%, the power actually increased power by 5%, and reduction of sample size by 10 to 30%. That's a huge reduction. So digital twins are this is kind of starting to implement in different areas. And it is not only in the healthcare, digital twins are in a different other domains also. But here, this could reduce the sample size by about 30%. That's the advantage. And this is another form of representation here. In original randomized control trial, we have treatment and placebo. But in the digital twin, we can reduce the sample size. We can add the digital twins here so that we get a reduced sample size and increased power. And based on this digital twin principle, we have there is a PROCOVA method. This is a prognostic covariate adjustment. This is based on the digital twin method. So this is also actually the same objectives are there. It's based on it creates a prognostic score from the control population, and the model trained on the that's obtained from the model trained on the historical control data. So this is what we discussed before. There's a standard randomized control trials. We have the patients, we randomize them into active or control arm, follow visit, then we analyze. But for analysis with the PROCOVA, we have the data and we have the historical data, and we derive a prognostic score using ML methods, and we do the clinical trial, and we have follow-up visit and analysis. But here we use ANOCOVA, or this analysis of covariance. In this model, we use include the prognostic score as well. So actually, what is prognostic score? Prognostic score summarizes baseline risk by combining covariates to estimate expected outcome under control. That means when the trial starts, like what would be the expected outcome? So that's a score obtained from the historical data. So this is the approach: train the prognostic model on historical control data, then generate a prognostic score for the current trial participants, and perform a linear regression with the current response. For the new trial, we can use the treatment plus prognostic score. So this is a model structure. I'm not going to details like the more mathematics on this, just for understanding. This YA represents the outcome of the ith patient. WI is the treatment group. This is either 1 for treatment or 0 for control. So this is the ANCOVA model, beta naught plus beta 1 WI. Then all these components, beta 2 age, sex, and all the other components. In the PROCOVA model, what happens is that instead of these all components, we can replace it with one prognostic score with that condenses this entire different sets of covariates. So prognosis score is the function of baseline variables of ith patient. So we can predict the prognostic score for each patient, and we can build this model. Okay, so this is a Procova is a like a proprietary item. Unlearn.ai got patent on this. So they proposed this method, and EMA, that is European Medical Agency, and FDA, Food and Drug Administration, the US, actually they agreed with this method of integrating this ML and the traditional data and the digital twins and all. So this is in place in different clinical trials. People are trying to explore the application of Procova. For example, the Alzheimer's disease. So far, we don't have any treatment available for complete cure, and it takes several years now. Even now that the trials are going on, under this scenario, we can use the historical control data to expedite the process. So they have shown this would improve the efficiency. So there are many advantages. So multiple baseline covariates are prognostically important, exceeding the number of that safely included. So if there are a lot of covariates, then we can replace that with a prognostic score. Then we can build the model. So there are like many. Some disadvantages are there. Prognostic value is concentrated in a small number of covariates. So under that scenario, there are small number of covariates. It could be challenging, and the relationship between covariates and outcome are linear and well understood. If it is well understood, the outcome and the covariates, if they are rightly correlated, then there is some issues. The non-linear combination, no. So I'm not going in detail here. So here is the Procova setup. Training data. Then we have the input variables from the baseline of the control trials. Then prognostic model built using a random forest algorithm. Then model validated on an independent data set to ensure reliability. Then prognosis score generated using prognostic model based on baseline covariates from the current trial. So from the current trial, we can generate a prognostic score. And the final Procova model. This is the final Procova model, a reduced model with a treatment group and a prognostic score. So this is one area where we use the historical data and available information to design a new trial with a more efficiency and like a reduced sample size and all. So another approach is the Bayesian method. That here also we can use the historical data, not purely AI method, but this is another innovative statistical application. Nowadays, this method is getting more popular. So rest of my presentation is based on one of our recent paper published 2 months back with my colleagues back in FDA. So it was this is a Bayesian application for pediatric population. That means this drug's name is belimumab. That drug was approved for the adult population, but the company actually wanted to get approval for the pediatric, that means the children. So what happens was like the company actually conducted another study on the pediatric population, and they submitted the data, and there were some issues with the data. So we decided to implement Bayesian statistics to support the approval of intravenous, that means IV dose of belimumab. So the rest of my presentation is based on how this trial got evolved and how what methods were used here. So let me start with the systemic lupus erythematosus, that is SLE, that is about 300 to 1.5 million people has affected by this disease. This is a severe disease, and 10 times more in female than male. And 15 to 44 years is the onset at this time when this systemic lupus erythematosus SLE got affected. So these are the symptoms like fatigue, loss of appetite, then butterfly rash, that is a common symptom, and inflammations are there, joint arthritis. It's a very painful disease. So here are some background. This belimumab, its trade name is Benlysta. It's a human monoclonal antibody. There were two types of administration. One is intravenous. Intravenous means direct to the vein. So the injections are there for the application of this drug, or subcutaneous. Subcutaneous means just under the skin. That's a subcutaneous injection. So there are two ways of like administration of this drug. Then phase 3 studies were conducted on adult population. Phase 3, if you remember the previous slide, the phase 3 is where we test in a big group of people to check the efficacy or how the drug is effective. So far, no treatment was approved for pediatric SLE. So for the children having this SLE, systemic lupus erythematosus, there was no approved treatment. So the applicant conducted a pediatric study. So in order to get approval, the applicant conducted a study on children. So what happens was, due to rarity of pediatric SLE, study was not adequately powered. So the thing is that because it was very difficult to recruit children to the clinical trial, the study was not powered. That means there were no required sample size to get statistically significant results. So that was one of the challenges in this study. So as a result of this, a Bayesian analysis was proposed, borrowed here is a historical borrowed information from the phase 3 trial in the adult population. So as I said before, there were two adult studies. So here, the data information from the adult studies were borrowed for this pediatric population. Okay, so that was the Bayesian application. So let me introduce the Bayes theorem. Maybe you may all know about it, at least you studied. So Bayes theorem is like, how could we learn probability of a future event occurring if we only know how many times it had occurred or not occurred in the past? So based on the past information, how can we predict the future? That was the essence of the Bayes theorem. So this is an example of Bayes theorem. The probability of having a cancer, we know that the probability of having a cancer is 0.05. Probability of being a smoker. So here the problem is that what's the chance of a person getting cancer if he is a smoker? So, but we know a probability of having a cancer for the entire group of people in an area, and we know a probability of being a smoker in a particular population. We know that probability also. And we also know that 20% of people with cancer are smokers. So 20% of the people with cancer, those who have cancer, 20% of them are smokers. That we know. Then we need to identify what is, if a patient comes to hospital, he is a smoker, what is the probability that he is having cancer? So with all these information, we can have a probability of that patient having a cancer being known that he is a smoker. So this is the essence of Bayes theorem, and this is being used in spam filters and other areas, like in our email system. This Bayesian rule is being applied. Like if an email comes with a term, say lottery, and what is the chance that that email is a spam? So that spam filtering is based on the Bayesian principle. So this is, there's some technical details of Bayes theorem. Not going here. Okay, so here in this study, what we use is that we use the historical information from the adult study, and we use that information in the current pediatric trial, and we try to check whether this drug is effective in the pediatric population. And the one challenge here is that how can we say that the adult and the pediatric are similar? Sometimes the adult population may have a different sets of value. Tolerance level will be different. So we cannot compare the pediatric subject with the adult population. So this is actually this borrowing is a continuum. Actually, this continuum means like if they are significantly different, adult and pediatric populations are significantly different, then we cannot borrow information from the adult population. And if are exactly same, if there is a no significant, there's a significant overlap. That means the adult and the pediatric group are the same, then we can borrow much of information from the adult population. And in between lies how this varies, this similarity varies. Based on that, the borrowing, we need to borrow the information. So we found that the Bayesian borrowing is an effective tool for this kind of a borrowing, where it is a continuum. We don't know exactly how much similar are they. So it's a kind of a continuum. So it's a wide range of possible scenarios. Yeah, this is what I said just now. So so here what we did was we implemented a post-hoc Bayesian analysis, borrowed information from the phase 3 studies. And so in the Bayesian analysis, there is a prior. So the prior is the already known information. So we obtained this prior from the historical trials. So here we use like a meta-analytic approach, but recently there are publications available. AI tools can be used for determining this the prior. So these type of like studies or like people are looking into that with the ML methods to implement for determining the prior. So then the weighting. So how much should be borrowed? That is a weight. So if weighting 1 means we need to borrow complete information from the adult population. 0 means no borrowing from the adult population. These components are there. So let me just go through these trials. As I said, there were 2 different phase 3 trials, and this is actually the phase 2 for the pediatric population. There were 40 subjects in the placebo and 53 subjects. These are children in this for the pediatric trial. These are the adult trial. Okay, I'm skipping this for the time. So the demographic characteristics. These 2 are the adult trials, and these are the pediatric trials. And the demographic characteristics largely similar across these studies. And so every trial there is a primary endpoint that for the for reducing sugar level, HbA1c. All these are the primary endpoints. So here the primary endpoint is SRI response rate at week 52. That is a combination of different like assessments, like the joint pain and all the how these scores, and that actually gives back to the response whether that patient is recovered or still under the disease. So these are the endpoints used in this study. And these are the results. So you can see that for the adult trial already, the odds ratio, the logistic regression was used, and it was found to be statistically significant because the confidence level excludes 1. And here also second study also is a statistically significant study. But here the pediatric trial, it was not statistically significant. And one problem was that, as I said before, the sample size was low, so it was not shown efficacious, this trial. So if the trial didn't show efficacy, then we cannot approve. From the regulatory side, FDA was not able to approve the trial. So then we try to, that's the reason why we borrow information from here. So this is what I said just now. So then what we did was like we reanalyzed the data using Bayesian method. So we use a logistic method, and we use a prior distribution from the historical data, and then combine collect data with the prior distribution to obtain the posterior distribution. So I'll say this. Okay, so here is the how we reanalyze the Bayesian methods. So this is the important thing here. The prior, actually this is called a mixed prior. Here we have the adult information from the adult, and this is kind of a vague information. So what happens if W is the weight? If weight is 1, that means weight is 1 means that we borrow all the information from here. 1 minus 1, this component will go away. So that means we can borrow complete information from this adult study, and we can combine it with the pediatric. So then suppose if these two population, adult and pediatric, they are different, then what happens is that we cannot borrow, then W is 1. So everything from here, that is a vague prior, so no information. Okay. Yeah. So as I mentioned before, this analysis was carried out for different weights, 0, 0.5. If you remember that a continuum across different weights, how much similar they are, we explored in different cut points for different weights. This is the actually the model. We use a logistic regression logic model, and the treatment effect beta 2. This is the prior W and 1 minus W. We obtain this information from the adult population. And here is the different weights and how this decision got changed. And if you see here, this is actually the Bayesian methods very like used for the for this approval. So here, if we give kind of a weight of 55%, that means if we say that the pediatric subjects are almost 55% similar to the adult, then we have enough information to exclude 1. That means this trial will become statistically significant. So what happened was, at this point, we discussed this with the clinicians and checked whether this is a reasonable assumption. So the clinician agreed that we can conclude this pediatric population would be somewhat 55% similar to the adult. Then that's kind of a added kind of a confirmation that we can take this weight and conclude that this trial, this drug is effective in the case of for the pediatric population. So this is a Bayesian method, purely Bayesian method to reduce, maybe this could be used to reduce sample size, because since we have a lot of historical data, if we can borrow information from the historical data, then we can reduce the sample size in this trial. So this could be a potential way. But here we use the meta-analytic method to obtain the prior information. But recently there are some studies. Okay, this is the summary what I just mentioned before. So if with a prior weight of 55% or larger on the adult data, provided 95% credible intervals that exclude odds ratio of 1, provide support for the evidence of the belimumab is an effective treatment in pediatric patients. So we conclude that having this assumption of 55% similar, then we can provide a supportive evidence. So then we also considered other secondary efficacy endpoints for this approval. So what I said before is that, like, so instead of so there are some methods are evolving. This is in the recent literature. Some novel methodology integrating generative artificial intelligence into a Bayesian inference framework. So this is a new area people started to explore, how the machine learning and generative AI to design, learn, or approximate prior distributions. So this could be a potential area where we can improve the efficiency of the trial, reduce the cost or sample size. So this is an active area where people started working on this. And there is like from the healthcare perspective, so because there are a lot of AI models, one challenge here is that which model to trust, because there are different models, and sometimes give different outputs or different recommendations. So then there should be some guidance is needed, some actually monitoring is needed. So FDA actually provided a guidance document for the artificial intelligence in the regulatory decision making. So see,
Pardon
once,
me, sir. We have a question in the chat box. I mean, it's a request in the chat box.
okay.
Could you please provide more details about the prior distribution and what are the AI-powered tools for Bayesian inference?
Okay, the prior distribution. Okay.
Yes, sir.
Yeah. So this is the prior distribution. We have the parameters like YP, that's distributed Bernoulli distribution, and the theta is assumed to be a logit distribution. With this is the model, the treatment baseline values and age group, and this is the beta coefficient with a mixed prior, where we use this is a weighted prior, where the weighting is added, as I mentioned before, how much borrowing is needed based on that. And this value, this is a normal distribution. This value is obtained from the previous trials. It's a meta-analysis. This value is obtained from the meta-analysis, and this is the standard deviation we derived from the previous data. And this is a vague normal distribution. That means like with a mean 0 and 8. This is a high variance we just randomly allotted. So if there is no borrowing happen, that means like this will be 0 and this would be 1, and only like a vague prior. So a flat prior will be there. And if more data being collected, so this will be a very accumulated around the normal value. So this is the prior distributions.
Sir,
yeah,
we have another query. AI tools to analyze nonlinear data. Do we have any specific AI tools to analyze nonlinear data?
On top of my mind, any particular tools? I don't know, but typically we can use like I personally use R, and there are like the packages available.
Okay, sir.
Yeah.
So do we have the data sets available? Like when you want to do the trial on this, do you generate your data, or do we get data available?
Yeah, so that's a good question actually. This data, these are all published, or these are all available. So actually in this case, like we need the historical trial data. But the problem here is that some data are like they are very confidential, because the healthcare data is very confidential. So under that scenario, we need to simulate. So if you go to for FDA related data set, you can go to the FDA website and you can find the summary of the data. It's the entire data is very like confidential. You may not get it. So under that scenario, we may need to generate or simulate the data.
So do we have any specific methods to simulate the data? Because these are really critical data. We cannot come to any kind of rough assumptions, since it's such a severe disease. SLE is such a severe disease.
Yes.
So we cannot come to assumptions about data. it will be almost near the values.
Mhm.
So do we have any specific methods to simulate data?
So one thing is that we need to use some statistical assumptions. Whenever we simulate the data, there could be some assumptions on the parameters. So other than
Yes, sir.
that, yeah, but we cannot compare the real data because this real data is not available. For example, if you generate like the binary data, then you need to have an assumption on the proportion.
Yes, sir.
Yeah.
So what are the parameters that we usually measure?
For
Now, when we consider this model, when you're going to apply the Bayesian methods,
mhm.
when we have to take the parameters, we have to consider the input parameters.
Yeah.
So what are the specific parameters that help us in making the correct assumptions or decisions?
You mean you simulate the data or?
Yes, whether it's for simulation or when you're taking a data set,
Mhm.
what will be the parameters or attributes or dimensions, features?
In the model, you say?
Yes, sir. Yes, sir.
Okay, so that's a good question. Actually, this model should be pre-specified. Actually, so in the clinical trial, like what's happening is that like the clinical protocol and SAP, statistical analysis plan, should be pre-specified and finalized before the database log, before we see the data. So that
Yes,
means
sir.
like, yeah, we need to specify those parameters. Sometimes
Yes, sir.
what parameters we think that more relevant. That's a joint decision by statistician or clinicians. So what parameters should go to the model. So typically, like in a regression setting, we can use like in a backward or forward, like the covariate finding things to determine like the components in the model. But for
Yes, sir.
clinical setting, we use like we predetermine these parameters.
Okay, sir.
Yeah.
Okay, sir. Thank you, sir.
Thank you. Very good questions.
Thank you, sir.
Yeah. Then I am about to end my presentation here. Yeah. Okay. These are okay. So why I just include this is that like I don't see much regulatory or regulations on AI methods. So if you are interested, maybe you can go to FDA and website and find this because they provide a nice framework on how to properly implement AI methods in a clinical trial or AI models like in an analysis framework. So it's a 7-step process. So I'm not going to details. You may go to this is publicly available information or document. You can refer to that and to understand. So whenever you build an AI model, this could be a good reference point to ensure that the model is properly aligned with the questions of interest, and there it is it's a credibility. It's also an issue of credibility. So because my point was like there are different AI models and tools, and sometimes most of the time it's kind of a very gray area. What's actually the model is doing, how this AI, the machine learning algorithm is working. We know the methods, but what's actually happening? For example, as I mentioned, like different R packages, they spit out different types of results. So for even in the statistical analysis, like there are multiple R packages, and these are different. For another issue, like if you compare, like in the clinical setting, like we use SAS or R, and there are differences between these outputs from SAS and R. So it's all like the methods and assumptions. But in the case of ML, is that sometimes we don't know exactly how this exactly gives these results. So that's why different models give different type of results. That's one challenge here for the AI models, like different agencies or different companies, they can develop different models, and there is no common kind of a regulatory body to say, okay, this is accurate, or comparing these models. So this could be a reference point when we develop any AI model.
Sir,
Yeah, yes.
sir, could you show me the previous slide, please? Yes, I just wanted to see the title that you had given, sir,
Mhm.
of the paper, AI driven.
Yeah,
That's it.
AI powered Bayesian inference. So this is the paper I just put in the here.
Okay, sir.
That's a 2025. That's publicly available. Yeah.
Sir, so the Bayesian model is professionally approved.
Mhm.
Is it like the model is approved that the predictions are correct with the Bayesian model?
Yes.
Yes. Sir. And how about, sir, with the ML or AI based models?
Yeah,
To what
that's
level do we have the studies till yet?
I'm not quite I don't know exactly because it's very recent paper 2025, so I don't see anything that is being implemented. Maybe I'm not aware, there might be. I don't know, but this is a very recent study.
Oh, okay. Thank you, sir.
Yeah.
Thank you so much.
Yeah.
So we have a question in the chat box.
Okay.
How descriptive and predictive type analysis can do using AI? Are there any AI tools for this? It's a question in the chat box.
Yeah. Descriptive and
And predictive analysis.
yeah, for I don't know like any tools because I'm not into that area much. But the thing is like we develop our own tools and agents, so I don't have anything on top of my mind right now.
Okay. Yes, sir.
Yeah.
Okay, sir. Thank you, sir.
Yeah.
Dear participants, any more questions? You can either enter into the chat box or you can directly ask.
Sir, I have a basic question. That is, while considering the databases or the data sets, you have told that pediatric databases are considered for adult cases. I mean, in your example, like pediatric cases have accounted into for the uh, adult analysis. How could we like? How could we correlate those two? They are. It could be entirely different, right, sir? Like, I mean, I didn't.
Yeah. No, no worry. Yeah, that's a good question actually. But there is one small difference is that the adult data is using in the pediatric. That's the only difference. And you made a good
Adult?
point. Yeah.
Yeah.
You made a
It's
good
not the
point.
yeah, it's not the pediatric data used into the adult cases, but the other way.
Yes, other way.
Okay, sir.
But your question is very valid. How can we say that they are same? Yeah, that's what we
Yeah,
try to
that is
address.
the thing. Yeah.
Yeah.
Because it all depends on the data set, right? Like, I mean, the attributes or the dimensions of the data set, and it will be entirely different.
Yeah, data set means that data resembles like data is from an individual, right? So
Yeah.
that how can we relate so the pediatric to the adult? That's
Adult,
like,
yeah.
yeah. So that's a good thing for a statistician. So I would say about statistics, like the good thing statistics is that we need to interact with the clinicians and different domain experts to check whether this is data, but how whether it is applicable or reliable or like meaningful, all comes from a discussion.
Okay.
Yeah.
So rather than going for the adult data, why couldn't we start from the infant data? Because treatment and analysis, if done earlier, would be better. So why did we start with adult data?
Yeah, that's a good question. Actually, the typical thing is like, the infants and the pediatric, they are so vulnerable. So if we start from them, so the issue is that like, we may not be aware like how if they can tolerate. So the typical pathway is to start from the adult. So once that is approved, then there is kind of a requirement for pediatric study. But there are some cases like some situations where this disease is more prominent among the pediatric group. Then we don't have any other option. We have to start from but still it's very slow process because we need to take care, because I am involved in an infant study, neonatal study. So we are very careful when we are dealing with the infants.
Okay, sir. Thank you, sir. Thank you.
Yeah. Thank you so much. If you don't have any questions now, I am really enjoyed, and it's very the questions are really good. So I know you are attending, and it's a good. And I'm thanking all the organizers, so Sharon actually contacted multiple times, and so it's a very good learning experience for me. And when we say like present something, that's like when we think more. So again, thank you for giving this opportunity.
Thank you, sir. The session was very clear and very explanatory type. Very good, sir. Thank you.
Thank you. Thank you. Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir. Thank you very much for your insightful presentation, sir. It's really useful.
Thank you.
Okay. Now I would like to invite Ms. Alina Matthew, Assistant Professor, Department of Computer Science, to deliver the concluding vote of thanks.
Good evening, everyone. On behalf of all the participants, I sincerely thank our distinguished speaker, Dr. Jindo J. Pottekar, for today's enlightening session on data-driven decision-making in healthcare using AI and innovative statistical methods. Your insights have not only deepened our understanding, but also opened new perspectives on how technology can truly transform healthcare. You have explained very well from the importance of data and its growth to how AI and its application with the help of statistics improve healthcare sector and its efficiency. The effort you have taken for this presentation truly helped us to gain knowledge in a lot of new topics. I also extend my gratitude to all participants for their active involvement. Once again, thank you, sir, for sharing your expertise with us. May this learning continue to inspire us in our teaching and research journey. Thank you.
Thank you. Thank you so much.
Thank you. Thank you very much, sir. And thank you very much, all the participants. Thank you.
Thank you,
Thank you.
sir, from our part also for joining us. Thank you.
Yeah. Thanks. Welcome. Thank you.
Thank you, sir. The feedback is already placed in the chat box. Participants, please fill the feedback.
Thank you, sir.
Thank you. Thank you for joining us.
Thank you, sir.
Thank you. Thank you for joining.
Thank you.
And see you tomorrow by 6 p.m. Good night and take care. Thank you.
After completing the feedback form, participants can leave the Google Meet.
But kindly remind to complete the feedback form. Thomas sir, good evening.
In the windows.